Alright, so in this video we're going to go ahead and discuss the fundamental theorem of calculus, and as you can see here we have the integral from a to b of some function, and we want to find its antiderivative or an antiderivative first, and then evaluate it at the limits by doing f of b minus f of a. So what we have here is an example. I want to find the integral from 1 to 2 of x squared minus 1 over x plus 1. And the first thing that I notice here is that I can actually factor out the numerator. So if I factor out the numerator, we end up having the integral from 1 to 2. The numerator becomes, let's see, x minus 1, x plus 1. And this is all over, again, the denominator, which is x plus 1. And then we have our dx right here. Now notice that we have x plus 1, we have an x plus 1 in the numerator and we have an x plus 1 in the denominator. So what I can actually do is go ahead and just reduce these or cancel them out. And what I would be left with is the integral from 1 to 2 of x minus 1. So this is a lot easier to evaluate. And a lot nicer to look at. It may be more appealing than looking at this thing right here. So sometimes we can use algebra to manipulate the integral so that it's feasible and we can go ahead and tackle this integral now. So what I want to do is now find the antiderivative of x and an antiderivative of 1. So what I can do is I can rewrite this as 1 half x squared minus x. So this right here is an antiderivative, and we are going to go from 1 to 2. So the part that I've reached so far, I'm right here at this step. So I've found an antiderivative, and what I'm about to do is evaluate it at the upper limit and then the lower limit, and I'm going to find the difference here. That's exactly what this statement right here says. So we're going to go ahead and do that. So this is going to be equal to, well, I simply plug in the upper limit, so I plug in a 2. So I will have, let's see, and let me do this in a different color here. I will have 1 half, and I'm going to go ahead and plug in 2. So I'll have 2 squared minus, and I'm going to plug in another 2. So I'm going to put that in a bracket. That is this right here. This right here is my f of b, capital F of b. And then I'm going to go ahead and subtract, so minus, so that's this part up here, this minus, and then f of a. Well, f of a is simply just this function right here evaluated at this, this number right here at 1. So we will have minus, now I'm going to plug in 1, so I'll have 1 half, 1 squared minus 1. And now all this this right here, let me label it like I labeled the other one. This right here is just f of a. And so what we have here is just an arithmetic expression that we can just compute, using basic arithmetic. So we'll go through this together here. 1 half times 2 squared. 2 squared is 4, so this is 4. And then I'm multiplying that by a half, so half of 4. So half of 4 is 2, but then I have a minus 2 there, so that'll go to 0. I'm going to leave it in brackets for now. And then we have minus, let's say minus, let me stick to the same color here, orange. We have 1 squared is 1, and 1 times a half, well, that's just a half, and then minus 1. Alright, so we know that 2 take away 2, we know that that's going to go, this will go to 0. So that's going to go to 0, and we're left with minus a half minus 1. So again, we're going to have the negative on the outside. A half take away 1. A half take away 1 is negative 1 half. And finally, negative a half and a negative, negative a half. Two negatives will make that positive, so our final answer is 1 half.